Good day everybody, my name is Gal. Today me and my team are going to do a lab on acceleration. We're going to use some simple materials to create 3 different graphs: a distance time graph, a speed time graph, and an acceleration time graph.
Hello, my name is Lada and I'm gonna talk about objective. Our objective is to study the motion of an object moving in a slope, given that there's no friction and we're not gonna consider about the air resistance. Our materials are wooden ramp, a meter ruler, stand, marble, stopwatch, and slow motion camera. First step, we're gonna place the ball post and off the ramp on the stand. Secondly, put a meter ruler against the higher side of the ramp. Then let the marble slide from the higher side to the end of the ruler. After that, we will measure the taken time using a stopwatch, and then we will record the data into the timetable.
Begin with a hypothesis. According to the fact that there is slope or tilt of the plane that the ball is moving down, we can say that mg is the force that acting down directly, and then mg cos theta is the force that acting down on the plane. But we are not going to consider about that because there's going to be a reaction force that pushing it up and cancel it. But what is really important is mg sin theta, which is the force that pushing ball down. And according to Newton's second law, F equal to ma. F is going to be mg sin theta, or the total force, and equal to ma. We can cancel m out, and we can conclude that acceleration is going to be g sin theta. Moving on to the graph, the first graph is going to be acceleration time graph. For this graph, the acceleration is going to be constant because according to what I proved before on this section. And then what about the velocity is that velocity gonna increase constantly because there is a acceleration which is constant. And then what about the displacement is that displacement gonna increase exponentially because there is a change in velocity, and when velocity is increasing, the displacement that an object can move is also increasing. So that's all for the hypothesis. Now, let's talk about data and statistics. This section will be similar to what I did on hypothesis section, but what is different is that there will be an actual result and actual data that we get from the lab. So, there are gonna be 3 graphs that I mentioned on this section. The first one is acceleration and time graph. We can say that the trend of the graph is pretty going in a straight line, and like I said before, acceleration should be constant due to the mg sin theta of the object acting down. And so when there is a constant force, that they're gonna be in constant acceleration. So I think the graph show the right information and prove the theory about Newton's second law. Secondly, the speed time graph. We can see here that the speed is increasingly constantly over time, which is like I said before in hypothesis. And because of there is an constant acceleration that I mentioned before on the last graph. And the last graph is time and distance graph, or distance time graph. We can see that it's increasing a bit exponentially because like I said before, when there is a change in velocity, the velocity is increasing. The distance that an object can move over a specific amount of time will also increasing too. So we can say that the distance that an object can move is increasing exponentially. That's it for the statistics and data.
Conclusion. We have 3 conclusions we studied today from this experiment. 1. As the time increases, the distance will also increase. 2. As the time increases, the speed will also increase. 3. However, the acceleration will be constant throughout the motion. Evaluation. In the next experiment, we would like to use an accelerometer to measure more accuracy of the acceleration. And we don't know the exact degrees the plane is tilted, so we can't compare the hypothesis to the actual results.
Is your birthday